We use the word scientist all the time, but have you ever stopped to think about what it really means? The answer is probably way cooler than you think. In this explainer, we're going to figure out what is a scientist.
Go ahead, take a second. When you hear the word scientist, what's the very first picture that pops into your mind? I'm willing to bet it's something kind of like this, right? The classic image. The person in the stark white lab coat, staring intently at beakers full of, bubbling, colorful liquids. It's a super common stereotype, but it's only one tiny, tiny piece of a much bigger, way more exciting puzzle.
So, let's peel back that stereotype. Let's see what's really going on underneath.
Okay, so on the left, you've got the cliché, the lab, the beakers. But this person on the right, that is also a scientist. A herpetologist, to be exact, studying a frog in its natural habitat. For her, the lab is the great outdoors. It's hands-on, it's adventurous, and it's a world away from that old stereotype.
Because when you get right down to it, a scientist is just someone who is incredibly curious. They're part detective, part explorer, part puzzle solver, all rolled into one. Their entire job is to look at the world, ask, why does it do that, and then try to figure it out. And that deep-seated curiosity, it's led to some of the most amazing breakthroughs in all of human history. Let's meet a couple of these incredible problem solvers who completely rewrote the rules. First up, Hedy Lamarr. Now, most people in the 1930s and 40s knew her as this glamorous Hollywood movie star, but what they didn't know was that she was leading a secret double life as a totally brilliant inventor. And her whole philosophy was about doing the unexpected. During World War II, she helped invent a top-secret communication system to keep Allied torpedoes from being jammed. This frequency-hopping idea she pioneered, it became the direct ancestor of the Wi-Fi and Bluetooth we literally can't live without today. That same passion for solving huge problems drove another scientist, Tu Youyou, to a completely different kind of discovery. Back in the 1960s, malaria was devastating huge parts of the world, and she decided to look for a cure in a really unconventional place: ancient Chinese medical books. And she actually did it. Her team sifted through over 2,000 ancient remedies before they found the key in sweet wormwood. The drug they developed, artemisinin, has saved millions of lives from malaria. She even won a Nobel Prize for it. It's just incredible. So what kind of tools are these world-changing problem solvers using? Well, it's probably not what you're picturing. The single most important tool isn't even a physical object. It's a process. It's the scientific method. Think of it like a recipe for finding things out. You start with a question, you make an educated guess, that's your hypothesis, then you figure out a way to test it, you collect the info, see what it tells you, and then you figure out what it all means. It's a system for getting to the truth. And this method gets used in jobs that can sound kind of scary, but are actually heroic. Like an ecotoxicologist might say they work with dangerous pollutants. And you might picture something pretty bad. But what they're really doing is figuring out how to protect entire ecosystems and keep plants and animals safe from harm. See the difference? And as for the physical tools, oh man, they are all over the place. Scientists use everything from massive supercomputers and sneaky remote cameras to simple things like rulers and stopwatches. And yeah, sometimes they do use beakers and microscopes. The toolbox is huge, but you know what? A lot of the time, the best tool a scientist has is just their own two eyes and a curious mind. And look, this isn't just stuff that's happening far away in a lab or a textbook. Science is woven into pretty much everything you do, every single day, in ways you might not even notice. Just think about the phone in your pocket. That whole journey started when scientists got curious about electricity. That curiosity led to inventions like the first telephone back in 1876. And after a century of more questions and more discoveries, it evolved into the little supercomputer you use to talk to anyone on the planet. $3. What's that about? Well, this is pretty amazing. Scientists, in this case economists, who study natural resources, figured this out.
For every $1 we spend on making sure people have access to clean drinking water, society saves $3 in medical costs later on. That's science with a real, tangible economic payoff. This powerful idea comes from the marine biologist Rachel Carson. Her book, Silent Spring, was this massive bombshell. She used careful, rigorous science to show the world how dangerous pesticides were. That book basically launched the entire modern environmental movement and directly led to the creation of the EPA in the United States.
Okay, now for the best part. You don't just have to hear about science. You can actually do it. Right now. We're going to create your very first wow moment.
I promise this is going to blow your mind, and you can do it at home. Go find some breakfast cereal that says iron fortified on the box. Crush it up into a really fine powder. Now dump that powder into a clear plastic bag or a jar with some water. Got it? Okay. Take a strong magnet and just swirl it around inside that cereal and water slurry for about a minute. Now pull the magnet out. What do you see? Those tiny, dark, fuzzy-looking bits clinging to it for dear life? That is actual iron. Real, literal metal. You just used a magnet to pull a mineral right out of your breakfast. How cool is that? And that feeling, that whoa moment, that's the whole point. Science isn't some secret club for geniuses in lab coats. It's a way of thinking. It's a tool for asking questions, and it belongs to every single person with a curious mind. That means you. I want to leave you with this incredible thought from Grace Hopper, who was a true pioneer in computer science. It's such a perfect metaphor for what science is all about. It's safe in the harbor, but that's not what ships are for. The real adventure, the real discovery, only happens when you have the courage to set sail.